Direct measurement of degree of thickening of cotton fiber is carried out using AFIS, HBI, caustic soda method, double compression method. If you have read about these, the measurement of thickening, it is also directly proportional to the maturity ratio, in which we calculate the maturity ratio of cotton fiber. It is 0.577 m. So if you have read, then you should know these machines also. So if you know about what is AFIS, AFIS is Advanced Fiber Information System. So this is AFIS. What is the role of AFIS? It is used for direct measurement. So all these things, if you notice, these are all indirect measurement techniques, whereas in AFIS it is a direct measurement of degree of thickening of cotton. So and on which principle does AFIS work? You should also know this. It is based on the principle of aeromechanical fiber processing principle. You should also know these kind of similar things on questions. These can be asked in your further gate questions. This is a 1 mark question. Coming on to the very next question. Scouring and cold mercerization of cotton are carried out by treatment with aqueous sodium hydroxide. The process parameters that differ in the two processes are. In this question, this is a typical 1 mark question. In this question, they basically ask what is the difference in the process parameters between the two processes that are used in the cotton processing. So if you know what is the use of sodium hydroxide, it is used as an alkali, but the concentration in scouring as well as in mercerization is different, as the role of these two processes are different, and depending upon the functions and the process the concentration, temperature and time varies in both the processes. So every parameter is different in scouring and cold mercerization. So option D is the right answer: temperature, treatment, time and alkali concentration. Now coming to the next question. Woven fabrics can be dyed in open width form in jigger, winch, jet dyeing and beam dyeing. So in which type of machine these fabrics are dyed in open width form? If you have read all these machines are very important for textile processing people and gate questions. So you should remember the individual functions, the rules, the process parameters such as M/L ratio, open width form, closed width form, the temperature, and which type of fabrics can be dyed in which machines. So these things becomes important, and you should know all these things, and these are very important, and these are asked every year. This is a direct question, and it is asked in the recent 1 mark question, and it is asked every year in one or the other form. So if you know in open width form, jigger and beam dyeing machine, the fabrics can be dyed in open width form in these two types of machines. In open width form, what is the meaning of open width form? In this type the fabric is held openly without the use of any closed kind of machine, and the fabric is runs speedily in the process. And in closed kind of dyeing kind of thing, it is surrounded by a closed machine where the temperature can be controlled, and whereas in open width form no temperature control can be done in open width form. So this is a basic difference, and jigger and beam dyeing machines can be used in open width form. Now coming to the next question. A pad bath for flame retardant finishing is prepared by mixing 300 gram per liter diammonium phosphate aqueous solution with 60 gram per liter softener solution in the ratio of 2:1 volume by volume. The concentration in gram per liter of the DAP in the resultant solution in integer is. So it is given that concentration of DAP is 300 gram per liter and concentration of softener is 60 gram per liter. So when it is mixed in the ratio of 2:1 volume by volume, then concentration of DAP and resultant solution is so the DAP is 2:1, so the concentration of 2 upon total into 3, and whatever be the concentration of DAP is 300. So it is comes out to be 100. It is 200 gram per liter. So it is the answer. So the answer in integer becomes 200. It is also a 1 mark question. So these are the simple maths questions, simple problematic questions in 1 mark question, and very complex textiles questions are asked in 2 mark questions. In 1 mark question generally they ask for basic understanding, basic level of textiles and simple formula based questions. So now coming to the next question. If the reflectance of the dyed fabric at lambda max maximum wavelength is 10%, then the color strength value K by S of the dyed fabric correct up to 2 decimal places is. You just need to know what is K by S value. Higher the K by S value, higher the color strength. So K by S is a color value, color strength parameter. So what is the value based upon the reflectance of the fabric? So if you have read, K by S is equal to 1 minus R whole square upon 2R. It is a formula of K by S value, and a reflectance is measured in an absolute terms. So if it is given as 10%, so 10 upon 100, it comes out to be 0.1. So just write the value 1 minus 0.1 ka whole square upon 2 into 0.1. 0.9 ka whole square upon 0.1. When you solve this, it comes out to be 4.05. So the answer should be given in 2 decimal places. So this is the 2 decimal places. 4.05 is the correct answer. So these are all 1 mark questions that I have discussed so far. This question is also assertion reason kind of question from textile chemical processing. In this question, the assertion that is given is in crease resist finishing process of cotton with DMDHU, curing is not carried out in steam. The reason that is given as the steam causes DMDHU to self polymerize rather than cross linking of cotton. So DMDHU, what is DMDHU? It is used in crease resisting finishing for of cotton process. Crease resist finishing means the cotton fibers in the cotton fabric, if you know, creases upon easily creases. So to avoid these types of finishing, certain crease resist finishes are used, and in this type of finishes, very common, very useful finishes with the DMDHU. In this DMDHU, it is polymerizes, and due to the cross linking of with DMDHU, the creases are the crease resist, matlab the crease formation is slowed down, and this type of finishing chemicals are used in crease resisting finishing. So the reason is true that curing is not done in steam. It is in this type, the padded fabric is dried at 80 degrees Celsius, and curing is carried out not in steam but at 160, 180 or 200 degrees Celsius, generally for 2 minutes. So it is not carried out in steam. So the assertion is true. and steam causes DMDHU to self polymerize rather than cross linking, but this is not true. So the assertion is true and the reason is false. So option D is the correct option. Now coming to the next question. Now the next question is also a 2-mark question from textile processing part. In this question it is also said that consider the following statements with respect to a cotton fabric which has been fully desized and bleached but not scoured. Means scouring is not done in a cotton fabric, whereas desizing is done to remove size and bleaching is done for better whiteness. So what are the typical components that are found in this kind of bleached and desized fabric which is not scoured? So the first option that is given, and it has residual seed coat fragments, it has poor water absorbency, third it has high whiteness index, and last one is it has high crease recovery. The correct combination of the true statements is, so if you know the process of what is desizing, what is bleaching, what is scouring, and if you relate all these things with the given options, then you can easily find the since in this type the cotton fabric is fully desized and bleached, so it does not contain any size because desizing is done to remove the size content, and also appear white due to the bleaching action that is done on the cotton fabric. But as it is not scoured, so it will contain the seed coat fragments and also have poor absorbency, because scouring improves the absorbency of the fabric and removes the other residual seed coat fragments. So option P is true, option Q is true, option R is true, and option S is not true because it has high crease recovery. The crease recovery is a functional finish that does not depend upon the desizing, bleaching and scouring, so the it is not at all relatable with crease recovery. So option S is wrong and option P, Q, R is true. So option A is the correct option. It is a 2-mark question. So coming to the next question. The next question is typical dye identification test method. In this question it is said that in a dye identification test, a dyed fabric is immersed in an aqueous alkaline solution of a reducing agent. The color of the dyed fabric changes and some dye bleaches out in a solution. The correct combination of the fabric and the dye is. So the in this question the typical results are shown ki how the color changes, what is the used reducing agent is used, or in what medium the reaction is carried out, and you have to find which type of dye is used and on what fabric it is used. So the options that are given is, first one is wool and acid dye, second one is polyester and dispersed dye, third cotton and wet dye, fourth one is acrylic and basic dye. If you know that the dyed fabric is immersed in aqueous alkaline solution of a reducing agent, it is possible that in case of wet dye with sodium hydrosulfite as a reducing agent for cotton fabric, so in case of wet dye, reducing agent is used in an alkaline solution. Which type of reducing agent is used in case of wet dye? It is used as sodium hydrosulfite, sodium hydro Na2S2O4. It is a sodium hydrosulfite is a reducing agent that reduces wet dye through a process of wetting, and then finally is used on cotton fabric. So in all other cases no reducing agent is used. In case of wet dye with cotton fabric, the reducing agent that is used as sodium hydrosulfite, it might be the best case, and this is the correct combination of the fabric and dye. Since the wet dye has very good color fastness and washing fastness on cotton fabric, then this is the best combination. So option C is the correct answer. It is also a 2 mark question. It is a numerical type of question. In this question, it is said that the Gibbs free energy equation for a system undergoing phase transition by is given by, this is the equation that is given as delta G is equal to delta H minus T delta S, where delta G is the change in Gibbs free energy, delta H is the change in enthalpy, delta S is the change in entropy, and T is the temperature in Kelvin. During melting transition, two systems A and B show no difference in delta H, means no change in enthalpy, but B exhibits 10% lower delta S than A. That means B exhibits 10% lower entropy. Change in entropy is 10% lower that compared to entropy in A. The ratio of the melting temperature of B to that of A rounded off to two decimal places is. In this question, we have to solve for delta G is equal to delta H. So the equation that is given as delta G is equal to delta H minus T delta S. So let delta S of A is equal to S. It is the change of entropy for a system A. So for delta S for B, it is 10% lower. So delta S for B, it is 10% lower than that of B. That means S minus 10% of A, 10 upon 100 into S. That means 0.9 S. Okay, it is given. And no change in delta H, means delta H of A is equal to delta H of B is equal to H is constant. Now we have to form from equation 1. This is equation 1. So if we take from delta G and delta H as constant, if we take delta G and delta H as constant, so the T delta S is constant. If we say, then T is inversely proportional to 1 upon delta S. T is inversely proportional to delta S. That means melting temperature, T is the melting temperature, delta S is the change in entropy. T A upon T B is equal to delta S of, if it is inversely proportional, then it comes out to be delta S of B upon delta S of A. For that, delta S of B, it is given as 0.9 S upon S. It is cancelled, then Ta upon Tb is equal to 0.9, and you need to find melting ratio of melting temperature of B to A. Tb upon Ta you need to find. Tb upon Ta will come out to be 1 upon 0.9. When you will solve, then it comes out to be 1.11. Rounded off to two decimal places, then the correct option would be 1.11 is the correct option. It is a 2 mark question. So just focus on the basics and you will solve it easily. Now coming to the next question. Cotton fabric is dyed at 5% shade on the weight of the fabric using a monofunctional dye, reactive dye. Monofunctional reactive dye means only the one functional group of the reactive dye reacts with the fiber. And the next thing that is given as the molecular weight of the dye and the cellulose unit is 400 and 342 respectively. If all the hydroxyl groups in the cellulose are accessible for reaction, the percentage of unreacted hydroxyl group of cellulose remaining after dyeing rounded off to two decimal place is. So the thing that is given is molecular weight of the dye is given as 400, and number of hydroxyl group, number of hydroxyl group in cellulose unit are 3 OH groups. So 3 OH groups in cellulose unit, 3 OH group. So the molecular weight of 3 OH groups is, 17, OH 16 and 1 hydrogen 17. So 16 plus 1 is 17. So for 3 into 17, that is 51. Since all the OH are accessible for the reaction, since it is written that all hydroxyl groups are accessible for the reaction, then the what is the effective weight? So this will react the number of unreacted groups. So this reaction is totally reacted. So molecular weight, effective weight for unreacted would be 400 is the total weight and it is reacted. So unreactive effective weight unreacted curve, so it will come out to be 400 minus 51, 349. So percentage unreacted, so percentage of unreacted OH group, so percentage of unreacted OH group will come out to be 349 is the weight and total weight is 351 upon 100. It will come out to be 99.4%. So this is the answer. In two decimal place, it is 99.40. Now coming on to the next question. A polyester fabric of 150 centimeter width and aerial density of 300 gram per meter square is printed at the speed of 60 meter per minute. The solid content of the print paste is 50%. After printing and drying, the aerial density of the printed fabric becomes 400 gram per meter square. The consumption in kg per hour of the print paste in integer is. So you need to find the production rate first. Production rate will come out to be, since the aerial density is 300 gram per meter square into 150 centimeter, means 150 upon 100 meter into what is the speed, 60 meter per minute, 60 meter per minute into 60 meter per minute, 60 meter per minute in kg per meter per minute to kg per hour. So if it we take out to be in kg per hour, so for kilometer 1 upon 1000 meter into kilometer, and for minute into hour we need to find write 1 upon 60 into 60. This is r upon 60 into 60, 1 upon 60 r. 1 minute is equal to 1 upon 60 hours. So it will come out to be 300 into 150 upon 100 into 60 into 60 upon 1000 kg per hour. If you will solve, then it will come out to be 1620 kg per hour. Then after printing, what is the production rate? After printing, the production rate will come out to be 400 gram per meter square. So 400 gram per meter square into 150 upon 100 into 60 into 60 upon 1000 on the same terms, just the aerial density is changed. Earlier it was 300, now it is 400. So it will come out to be 2160 kg per hour. We have done this to keep the units same, that is the production rate in kg per hour. So if you will compare the fresh one with the new one, earlier the production rate was 1620, now the production rate is 2160. So what is the increase in the fabric weight? If you have done printing, then there is increase in the weight due to the weight of the print paste also, because the print paste also carries some weight. As you can see that the aerial density, the GSM of the fabric earlier was 300 and after printing it was increased to 400, as the print paste and also contains heavy weight. So how much the fabric weight is increased, we can write here. Increase in fabric weight, increase in fabric weight will come out to be, increase in fabric weight will come out to be 2160 minus 1620. It will come out to be 540 kg per hour increase in fabric weight. So, and also it is given that the solid content of the print paste is only 50%. That is, only the 50% is solid content paste. So how much will be the consumption of the print paste? Let the consumption is 50%. So the total weight is x into 50% is reacted only, and that comes out to be 540. So when you will solve 540 into 2, then the weight will come out to be 1080 kg per hour. In integer, the consumption in kg per hour of the print paste in integer is, so the answer is 1080. This is the answer. I think by now you have understood how the gate questions are asked and how to solve them. This is not a very typical type of question, just you need to clear with the fundamentals of textiles as well as the basic formulas. You should focus, you should be mentally aware what thing is asked, what thing is given, what to do, and how to focus on numericals, how to focus on the units given, because they play with the units. Because many times the questions, if you just see the units very carefully, then you can easily solve this question irrespective you know the technical fundamentals or not. So just focus mentally, be aware, and I think this gate series will help you a lot. This is the typical solution of a gate 2022 textiles part. I think you have liked this video.